Now let's try putting scientific notation numbers in order from least to greatest. What you can do is change all of these back to the decimal form if you would like. Let me just show you what these two would look like. I'm going to actually leave these as scientific just because it's going to be a lot of zeros and decimals and stuff. So the first thing we know, negative exponents are going to be smaller numbers, and remember, negative exponents are going to be really small numbers, positive exponents are going to be big numbers. So we know that the negative exponents are going to be the least, but we have to figure out which one is the smallest of those. Now, 1 times 10 to the negative fourth, again, negative means we're going to move to the left 1, 2, 3, 4. So this would be 0.0001. Now this also means to the left, but I'm only moving once. So this is really just 0.125. So we can kind of get an idea of, okay, if both exponents are negative, the negative 4 is going to be much smaller than, say, a negative 1. So that's one thing to keep in mind. Okay, so I'm going to look at my negative exponents. I have a negative 2, a negative 3, and a negative 2. So I know that negative 3 is going to be the smaller one because we're going to go farther to the left. So I will write 2.5 times 10 to the negative third. That's the smallest number. But now I've got to decide between 1.6 times 10 to the negative 2 and 2.8. Now, 1.6 to the negative 2 would be 0.016. 2.8 to the negative 2, 1, 2, would be 0.028. So now I've got to figure out which one is smaller because they both have the negative 2 exponent. So the smaller one is going to be this one right here, 1.6, because obviously 1.6 is smaller than 2.8. So then we put 1.6 times 10 to the negative second, 2.8 times 10 to the negative second, and now we're ready to look at our positive 6 exponent. So these both have the same exponent. I think 1.4 is smaller than 5.6. So then I'll put my 1.4 and my 5.6. So again, we're just ordering the numbers from least to greatest. Now let's double check to make sure we have them all. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we do.